Hello, good afternoon, everyone. This session is over decision tree based classification. Like we were earlier discussing, classification is a type of supervised learning technique where the data set is available for you along with the labels. For example, if the class teacher of 60 students is asked to divide them into two groups, a group of dancers and a group of singers, this process will be called classification. Why? Because you have two labels available. That is, one is a group of dancers and the other one is a group of singers. So what the teacher does is that the teacher asks for a student's for its preference, and as per the student's preference, the student is put up in the group either of the dancers or of the singers. In the other case, if the teacher is only given a task of dividing the students into two groups with no information provided or no label assigned to these two groups, it is upon the teacher to decide how the teacher will divide them into two groups. For example, the teacher can divide them into a group, say for the students who have scored less than 50 in a subject will be put in one group and more than 50 in a subject will be put in the other group. Or for example, if the students who have a set of hobbies, say cultural, they are put in one group, and students who are interested in sports will be put in the other group, which means it will be based on a feature that a teacher decides. This process where the labels are not available is called unsupervised learning. Like we've seen, classification falls under the category of supervised learning, whereas clustering falls under the category of unsupervised learning. In classification, as we've already seen, the entire data set which has labels mentioned in it is divided into two data sets. One is the training data set and the other one is the testing data set. The training data set is used for training a model that can later on be used for predicting labels for newer set of tuples, whereas the testing data set is used for verifying whether the model is accurate enough to give you the right predictions or not. Now, one category of these classification models is classification using decision trees. This is the topic for today. We'll begin with what a decision tree is. Now, when you talk about decision trees, there are three major characteristics that can describe a decision tree really well. The first characteristic, as you can see here, is called recursive partitioning. The other characteristic is that they are built in a top-down approach. And the third characteristic is that they are built using a greedy search technique. Now, what do we understand by recursive partitioning? What is happening here is, if you see the detailed structure of a tree that is shown here in this image, left side is the data set wherein you see 1 to 7 tuples. Work to do, outlook, and friends busy are three attributes for which values have been assigned in each tuple. And the fourth attribute is your actual class or label. Now, I'll just give you a brief description about the data set, what the data set is doing. The data set here contains records of different candidates. Now, what happens is that I ask somebody, do you have any work to do? The person says yes or no. Now, if the person says yes, what are the options available? And if the person says no, what are the options available is our prediction of the class. So you ask the person whether the person has work to do. Outlook is describing how the atmosphere outside is, and friends busy is if a person is free and the atmosphere outside is suitable enough to go out, are the friends available to go out together or not? This is how the data set is. Like, this is the information that the data set is containing. On the right side, we've made a decision tree for the same data set. What is happening here is, now, like you can see in the data set, the attributes other than the label have been marked in green color. All that you see marked in green color in your decision tree on the right side are your attributes, which means the root or the parent, the foremost parent node in this decision tree is work to do is actually an attribute. Outlook is an attribute, and friends busy is an attribute. What next do you see? Yes, sunny, rainy, overcast, no. All of these are values assigned to these attributes that you see marked in orange. Here, on the right side in the decision tree, you can see the branches have been marked in orange, and the branches have the naming of the same values that were assigned there. For work to do, we can see yes and no. For outlook, we can see sunny, overcast, and rainy. For friends busy, we can see yes and no. The third category is the labels. The labels, we see three unique labels, actually four here. One is stay in, the other one is go running, the third one is go to beach, and the fourth one is go to movies. You see they're marked in purple on the right side in the decision tree. So what makes us understand that, like, how did I mark these? What is happening here is the root node as well as all the internal nodes that you see in a decision tree are actually attributes. All the branches are the values to these attributes, and all the leaf nodes are actually the classes or the labels that we are supposed to predict for the newer tuples in this data set. Now, one algorithm that is the core algorithm used for building these decision trees is called ID3, which stands for Iterative Dichotomizer 3. This is the algorithm that is used for building decision trees. Now, in layman terms, if I tell you how do you build this decision trees, if you see on the right side where you see the decision tree, you can see that the first attribute or the parent node, the foremost parent node, is work to do. The second one is Outlook, and third is friends busy. Why is it that I placed work to do first and not Outlook first? Or why is it that I placed work to do first, not friends busy first? Or why is it that I placed Outlook second and not friends busy second? So there has to be a reasoning behind selecting the order of these attributes. So that is what the functionality of iterative dichotomizer algorithm, that is ID3 algorithm, is. There are three different kinds of indices that are used for calculating the order of these attributes in a decision tree. You can see the last line mentioned here is the order of splitting point. These attributes are actually called the splitting points in a decision tree. These splitting points are chosen on the basis of either of these three indices that we will be seeing next. You can see we have section for each of them. One is information gain, the other one is gain ratio, and the third one is Gini index. How do you calculate it? We'll be seeing now. But before moving on, I'd like to tell you that we were discussing the three characteristics, wherein the first one was recursive partitioning. As you can see here, the entire data set was first questioned on the basis of work to do. So in all, I've got 7 tuples in the data set. Now, if I ask you work divided on the basis of work to do, you will divide it into 2 data sets, wherein the first data set that says yes is going to have 1, 2, and 3 tuples out of the entire data set, whereas the no data set will now have 4 tuples. So the initial data set is divided into 2 different data sets, which are smaller in size, which means you have partitioned the data set. Now what's happening is on the right hand side, the data set with the no is questioned on Outlook. On the basis of Outlook, it is dividing it again into 3 data sets, one for sunny, one for overcast, and one for rainy. So the one with sunny is going to have 1 value or 1 tuple. The one with overcast is again going to have only 1 tuple, whereas the rainy one is going to have 2 tuples. So what you did is that initially the entire data set, which was divided into 2 subsets, is now again divided into 3 more subsets. So this is the process wherein you recursively partition your data set. That is why they say that these decision trees are based on recursive partition. Now, as you can see, we started with the first attribute. How do you select the attribute is the other aspect, but you started with one attribute, then you took the other attribute, and so on, which means it is a top-down approach of building a decision tree. When it comes to greedy search, I think you'll understand what is why do they say that it uses greedy search as we see the other techniques, these indices. But for now, all you need to know is, when do you say that you made a greedy search? Greedy techniques basically mean that out of all the options available, you do not go for the best option, but you go for a locally best option. So if I say that say that like we talk about our own university. Now, if I say that the lift turns off, or the light goes off and the lift is down, or the lift doesn't work at many times, right? So what happens is that right now when the lift, this is my own personal example that I've seen. So if I say that the lift is not working, what we do is that we turn it off and we turn it on again, so it starts working. So we haven't actually found out what was the issue that is actually causing the lift to stop again and again. So this was a local solution that we brought. Now the global solution actually should be that we should call a technician. The technician should find out the problem and get the solution forever. Like it should be a lasting solution or the final solution. But rather than going for that global solution, as of now, we went for the optimal most solution, that the best solution right now could be that you turn it off and turn it on so that the people inside can come out. So that was a local choice that we made rather than going for a global choice. So that is greedy search. We'll see how decision tree is made using greedy search when we see these indices. I hope so far everything is clear. You understood the structure of decision tree, how is a decision tree made, and a basic overview of the iterative dichotomizer algorithm. All right, so moving further, we'll now see how do you classify using decision tree induction. Okay, so as I said that we'll be using the indices to actually select the splitting point or the attribute, the order of these attributes. What is going to happen is on the left hand side you can see the data set, and on the right hand side you can see what are the steps. So as you see for the first step, what happens is that out of the three of them, I'm right now selecting information gain as the index. Information gain, gain ratio, and Gini index. All three solve the same purpose. All three can be used for selecting the splitting point. So at a time, you can make use of only one of it, right? So right now I'm selecting information gain. What happens is that you have to first of all calculate the information gain for all the three attributes: work to do, outlook, and friends busy. After calculating it, how to calculate, we'll come to that. But for now, you understand that you've calculated the information gain value for work to do, outlook, and friends busy. After calculating these values, you can see the information gain for work to do comes out to be 2.34. These are random values that I've taken just to show you how it works. Information gain for outlook is 1.28 and information gain for friends busy is 1.97. Out of three of them, you see the highest is 2.34. That is the information gain for work to do. That is why work to do is selected as the first splitting point. After selecting it as the first splitting point, you can see that we've divided the data set into two parts on the left hand side here. See, so these are the two data sets that you see. What happens now is that on this data set, you calculate the information gain for outlook and friends busy. Whichever of them is higher, you take it up and again partition the data set. Whereas for right hand side, again, you calculate outlook and friends busy information gains respectively, and whichever is higher, you pick up that one for partitioning. Now see, there can be a possibility that on the left hand side in this data set, you get the information gain for outlook as higher, whereas on the right hand side, you get the information gain of friends busy higher. So that is how it will work. So on the left hand side, you take up outlook first, and on the right hand side, you take up friends busy first. Depends completely on the value that has been calculated using whichever index you are selecting. I hope this much is clear, everybody. So how this is going to work is clear. We can now move to the first index, that is information gain. That how do you actually calculate the information gain? Okay. So for this, you'll have to sit with a notebook and a pen so that you can solve it on your own, which will give you a better understanding and will help you easily solve the practice questions that are going to follow. All right. So you see the data set here. Here is the data set. We have got three attributes, out of which the third one is the label. The first attribute is age, the second attribute is income, and the third attribute reads loan underscore status. What is happening here is that this is the example that we've been discussing for so long in all the lectures, that I ask you what is your age and what is your income, and on the basis of that, I am deciding whether you will be granted loan or not, right? Okay, so that's how the data set is. We've got 6 different tuples. For age, we have got 3 unique values: youth, middle, and senior. For income, we've got 3 different values: low, medium, and high. For loan status, it is either yes or no. These are our labels. So we've got 2 labels in all: yes and no. All right. On the right hand side, you see this decision tree wherein I've marked age first, youth, middle, senior, then comes income. For youth, you're questioning the income: low, medium, and high. For middle age, low, medium, and high. For senior, low, medium, and high. How did you build this decision tree is what we're going to see now. So These are the formulas used for calculating the information gain. Now in information gain, there are total 3 formulas. The first formula, as you can see, is information of the data set, that is equal to negative summation of I equals to 1 to n pi log pi to the base 2. Now what does this mean? I'll go one by one. This pi is actually probability. I equals to 1 to n means number of unique labels. In our case, we have got 2 labels, that is yes and no. So I equals to 1 to n is going to be 1 to 2. Pi log pi to the base 2 means that for the first label, that is no here, you have to calculate the probability of no, which means out of 6, how many no's do you have? You can see there are 4 no's, right? So this is going to be 4 by 6 log 4 by 6 to the base 2, plus for yes we have got 2 yeses, so it's going to be 2 by 6 log 2 by 6 to the base 2. You can see that calculated right here. Info data set is equal to, since we have only got 2 labels, no has got 4 tuples, yes has got 2 tuples. So what we did is, now since this is a negative term, what we do is that after adding them, you ultimately have to put up a negative sign. So I've written minus 4 by 6 log 4 by 6 to the base 2 minus 2 by 6 log 2 by 6 to the base 2. This is actually this formula wherein you calculate it for each of your label. Now using a calculator, what you do is, I just help you understand this log 4 by 6 to the base 2. How do you calculate it? What I did is I first calculated 4 by 6 log to the base 2. You have to understand that there's a difference between base 10 and base 2. Hence, log 4 by 6, this is going to be log 4 by 6 divided by log 2. And that's how you get the value. You multiply it by 4 by 6. And whatever it is a negative term, which ultimately will turn positive because this value itself is going to be negative. All right, you calculate it using a calculator. For any queries related to this, you can then later on ask me. But how you calculate, you remember log 4 by 6 divided by log 2 will give you this answer. This will directly not be available in your calculator. All right, okay. So I hope you're understanding how do you calculate this term, the data set, information data set. Okay. Moving further, now we see how do you calculate info attribute. As you can see, what they write is summation of j1 to v dj upon d into info dj. How do you interpret this? We'll see here. As you can see, we've calculated it first for age. Now in age, you see that there are 3 unique values. Youth has got 2 tuples, middle has got 2 tuples, and senior has got 2 tuples. So we first take up youth. What we do is, youth is 2 out of 6, so we write 2 by 6. In the bracket, what you write is the same formula that you applied here for yes and no is going to be applied here. Only difference is that there yes and no was for 6 tuples, whereas here you are only writing it for youth. So youth only has 2 tuples, so you calculate it only for 2 tuples. So you see, youth is here and youth is here. So one youth has got no, the other youth has got yes, which means it is going to be 1 by 2, 1 by 2 each. That's why we write 2 by 6 in the bracket minus 1 by 2 log 1 by 2 to the base 2 minus 1 by 2 log 1 by 2 to the base 2, plus the second value for age is middle. Middle also has got 2 tuples, as you can see here, 1 and 2. This tuple says no, this tuple says yes. So again 1 by 2, 1 by 2. So we write 2 by 6 in the bracket minus 1 by 2 log 1 by 2 to the base 2. I've forgotten base 2 here. Minus 1 by 2 log 1 by 2 to the base 2. It always has to be, all this calculation is with the base 2. You have to make sure, I forgot putting the value, but I have calculated it using base 2. All right. The third unique value is senior. You see, we have got 2 tuples for senior. Both of them say no, right? Okay. So what we do is, now there is a problem in my calculation here. I hope you guys rectify it. I have actually mistaken it to be yes. So what you do is, the correction will be 2 by 6 bracket minus 2 by 2 log 2 by 2 to the base 2 minus 0 by 2 log 0 by 2 to the base 2. I request you all to make this correction here. There is a calculation mistake made by me in information for age. For youth, there were two tuples, so we wrote 2 by 6 in the bracket. For youth, you see one tuple says no, the other one says yes. So it's going to be 1 by 2 each. So we write minus 1 by 2 log 1 by 2 to the base 2 minus 1 by 2 log 1 by 2 to the base 2. For middle, again, we've got two tuples. One says no, the other one says yes. So 2 by 6 in the bracket minus 1 by 2 log 1 by 2 minus 1 by 2 log 1 by 2. You understand that this one is for yes, this one is for no. Yes, no, yes and no. All right. So for the third one, for senior, we've got both no's. I have made a mistake here. You do not do that. 2 by 6 in the bracket minus, for yes it is going to be 0. So minus 0 by 2 log 0 by 2 to the base 2 minus 2 by 2 log 2 by 2 to the base 2. You calculate the value and you will get some answer here that you are supposed to do on your own. Okay. So once you have found out the information value for data set and the information value for age, the information gain for age, the formula as you can see here, the information gain for attribute is going to be information data set minus information attribute. So the value that we got for data set, you pick the value from here. You've calculated it here, 0.924 minus the value for info attribute that you will get the corrected value. Put it in the formula and you get the information gain for age. Similarly, you calculate it for income. How do we do that? For income, everybody just check. How many unique values we have for income? 3, low, medium and high. We first go for low. Low is 2 tuples. So we write 2 by 6 in the bracket. Low has got both no's. So what do we do? Minus 2 by 2 log 2 by 2 to the base 2 minus 0 by 2 log 0 by 2 to the base 2. This stands for no, this stands for yes. You can change the order. It is not going to make a difference. It is simple addition, right? So, okay. The other value is medium. Medium again has got 2 tuples. So 2 by 6. One medium says yes, the other one says no. So it's going to be 1 by 2 and 1 by 2. So what do we do? Minus 1 by 2 log 1 by 2 to the base 2 minus 1 by 2 log 1 by 2 to the base 2. The third value is high. We've again got 2 tuples for it. One says no, the other one says yes. So it's going to be again 1 by 2 and 1 by 2. So we write 2 by 6 in the bracket minus 1 by 2 log 1 by 2 to the base 2 minus 1 by 2 log 1 by 2 to the base 2. I hope it is clear now. You calculate the value. Again, we have info data set. Remember, the info data set is going to remain common for all the attributes. Info attribute is going to be different and information gain attribute is going to be different. So again, for income, 0.924 is the value of the data set minus the info income. Why have I written plus here? Because minus is going to be plus. I hope you understand that. You add the value here. Okay. So whatever values. Now, since this value will be different, you verify what the answer is. In my case, I got information gain age as 2.904, information gain income as 2.244. Now, when you compare 2.904 and 2.244, 2.904 is greater than 2.244. Hence, the information gain of age is greater than the information gain of income. And that is why age becomes the first splitting point. And we put age first and then we put up income. I hope it is clear to you. How do you calculate the information gain? I repeat, you first have to calculate the information of the data set. How do you calculate that? You have to see that there are how many labels available. So we've got 2 labels, yes and no. So you put up in this formula minus no matter how many tuples, 1, 2, 3 and 4. So it's going to be minus 4 by total tuples is 6. So minus 4 by 6 log 4 by 6 to the base 2 minus, yes, we've got 2 tuples, 1 and 2. So we say minus 2 by 6 log 2 by 6 to the base 2. So this data set is common for all. You calculated it. Now for age, you calculate info. How do you do that? How many unique values? Low, age is youth, middle and senior. So for youth, how many tuples? 1 and 2. So we write 2 by 6 in the bracket. The first youth says no, the other youth says yes. So you write minus 1 by 2 log 1 by 2 to the base 2 minus 1 by 2 log 1 by 2 to the base 2. One signifies yes, the other one signifies no. Plus, for middle again, you've got 2 tuples. One says no, the other one says yes. So 2 by 6 minus 1 by 2 log 1 by 2 to the base 2 here, minus 1 by 2 log 1 by 2 to the base 2 here as well. The third one is senior. Both of them say no, I made a mistake here. Kindly rectify when you solve it on your own. 2 by 6 in the bracket, it's going to be minus 0 by 2 log 0 by 2 to the base 2 minus 2 by 2 log 2 by 2 to the base 2. The answer is going to be something. What next? You subtract this value from the info data set and you get some value. You calculate the similar thing, that is the information for income. Again, you calculate the income value from data set and you get this value. Now you compare these two information gains. You get information gain of age as higher to the information gain of income, and hence in the decision tree we put up age first and then income. I hope you understand now. Now see, there can be a possibility. Now here we are dealing with only 2 attributes, that is age and income. Now if you deal with 10 different attributes, there is a possibility that in the first place when you calculated, see this is age. For example, if you get age as okay, so if you get the info of age, information gain of age as 5, the information gain of income as 6, and the information gain of say X attribute as 7. X attribute is the highest, right? So you will place X attribute at first place. Now on the basis of X attribute, you will partition the data set. In the partition data set, you get the information gain of income lower than age, right? Earlier, oh sorry, age lower than income. So earlier in the initial example, we got age as 5, income as 6, and X as 7. After partitioning, I get age as 6 and income as 5. So earlier, although income was more than age, in the partition data set, my income has got a lesser value than age. So age will be selected first, right? Which means we are taking a decision locally and not globally. Although globally over the entire data set, income has got a better information gain than age, but the highest one was already selected and we partitioned on the basis of highest one, that was X. When comparing age and income over the data set, income was better, but on the partition data set, age comes out to be better, and hence you select age first in the partition data set and then comes income. So this is that you made a local choice and not a global choice. Although the global optimal solution was different, but you went for the local optimal solution. That is why we say that the decision trees make use of greedy technique. I hope that greedy search characteristic is now clear. If you want me to repeat it, I'll just repeat it once again. Say for example, that when you calculated at this stage, when you have the entire data set, you say that there is one more attribute called X, right? You calculate the information gain for age, income, and X. Age was 5, income was 6, X was 7. So 7 is the highest. So you put X here and partition the data set. After partitioning this sub data set, the sub data set or the sub tree, you calculate the information gain for age and income both. Now here, age comes out to be 6 and income comes out to be 5, which means that although over the entire data set, the information gain from income was higher than age, in the partition data set, the values have changed and age has got a higher information gain than income, right? In that case, we are going to select age and not income. That is why they say it is a greedy search, that you don't make the decision on the basis. We're not following this technique that khali ek જ बार calculate કરીને you put up age first, then you put income, and then you put up X, income, and age in one go. That's not possible. You divide it into subtrees and then you again calculate the information gain. There is a possibility that locally there can be a difference in the values. So now you understand that that's how we've taken up a local decision and not an optimal decision globally. And that's why they say that decision trees make use of greedy search. All right. So after information gain, we are moving to the next indice. Just a minute. Okay. Yes. Okay, so we move on with the next, that is the Gini index. Okay. So what happens here is we are making use of the same data set. Like you see, we've got age, income, and the loan status label. All right. Gini index has got these formulas. The first formula, as you can read, the Gini data set. Like in the information gain, we had the info data set. Here we have Gini data set. What does Gini data set say? 1 minus summation of I equals to 1 to n pi square. Now, if you remember, pi was what? How many unique labels do you have? Yes and no. For no, your pi value was 1, 2, 3, and 4 out of 6. So 4 by 6. For yes, your pi value was 2 by 6. So what happens here is, I hope you have understood by now, we've calculated it here. Gini for the data set is going to be 1 minus 2 by 6 whole square minus 4 by 6 whole square, which means as many unique values in labels you've got, you subtract it from 1. So 1 minus 2 by 6 whole square minus 4 by 6 whole square, you get a value. Okay. Now you see for each attribute, Gini for an attribute, like we had info for attribute. What does this say? More or less the same kind. So we directly go to the solving part. Okay. So Gini for age, how many unique values do you have for age? One is youth, the other one is middle, and the third one is senior. For youth, you've got 2 tuples out of 6. So you write 2 by 6 in the bracket, 1 minus, out of these 2 youth, what is the status of yes and no? So one youth here says no, the other one says yes. So what you do is 1 minus 1 by 2 whole square minus 1 by 2 whole square. You understand, for youth, we are seeing how many yes and no. Here in the entire data set, we saw how many total yes and no. Here for each attribute, we are checking how many yes and no. Plus for middle, how many tuples? 1 and 2. So again, we write 2 by 6. For middle, one says no, the other one says yes. So you say 1 minus 1 by 2 whole square minus 1 by 2 whole square. And for senior, again, you see there are 2 tuples, both of them say no. So what you do here is, again, I've made a mistake here. You guys, please do not make it. I considered it as 1 yes and 1 no. Okay, so 2 by 6, 1 minus 0 by 2 whole square minus 2 by 2 whole square. It is going to be, and not 1 by 2, 1 by 2. As you can see, both the senior have got no. So you make sure you don't make the mistake. 1 minus 0 by 2 and 2 by 2 it is going to be. I hope this much is clear. So next what we do is that I've calculated it for income as well. Again, income has got 2 lows, so it's going to be 2 by 6 in the bracket, 1 minus, both the lows say no. So what we do is, since both knows, 1 minus 2 by 2 whole square minus 0 by 2 whole square, plus medium, 1 no, 1 yes, so 2 by 6, 1 minus 1 by 2 whole square, 1 minus 1 by 2 whole square. High, 1 no, 1 yes, again 2 by 6, 1 minus 1 by 2 whole square minus 1 by 2 whole square, you get a value. Now what you do is, the Gini index is going to be entire data set minus the attribute. So 0.44 minus 0.51 will be different for you because I've made a mistake there. So you get some value. For income, again, the data set minus this value, you get 0.11. Whichever comes out to be higher will be selected. So here income will be selected, and this decision tree is going to be different. And here income is going to be the first attribute, and then you come to age. I hope that much is clear, everybody. I repeat it again just for people who've missed out. The formula says 1 minus summation of pi square. Pi, like in the last example, is unique labels. We've got 2 unique labels, yes and no. What we do here is 1 minus, for no we've got 4, for yes we've got 2. So 2 by 6 whole square minus 4 by 6 whole square. We calculate the Gini for age. Age has got 3 unique values. For youth, 1 and 2 tuples. One says no, the other one says yes. So 2 by 6, 1 minus 1 by 2 whole square minus 1 by 2 whole square. Plus middle, we've got 2 values. One says no, the other one says yes. So 1 minus 1 by 2 whole square minus 1 by 2 whole square. Senior, we've got 2 values. Both say no. So it is going to be 2 by 6, 1 minus 0 by 2 whole square minus 2 by 2 whole square. Calculated for income as well. Gini age and Gini data set we've already calculated. So Gini index is going to be data set minus age. That's this. For income, you calculate the same way. Whichever is higher is selected first. Okay. We said that there are 3 indices. One was information gain, the other one was Gini index, and the third one was gain ratio. So the gain ratio here is, you read the formula, the gain ratio age is going to be equal to information gain of age that we have calculated in the previous example here. This information gain of age, which means your gain ratio is completely dependent on your information gain. So whichever formulas are available for information gain have to be used in gain ratio also. You have to calculate till here. Till this point you are supposed to calculate, right? Then what you do is, there is divided by split info of age. How do you calculate the split info? There's a formula given here, summation I equals to 1 to n dj by d log dj by d to the base 2. We calculated. How do you do that? See here. I'm calculating the split info for age. How many unique values? 3. Youth, middle and senior. 2 youth, 2 middle, 2 senior. So what do I do? Out of the total tuple 6, it is going to be minus 2 by 6 log 2 by 6 to the base 2 minus 2 by 6 log 2 by 6 to the base 2 minus 2 by 6 log 2 by 6 to the base 2, which means as many unique values you have for age, you're taking account of all of them. For youth, we did 2 by 6 log 2 by 6 to the base 2. For middle age, we did 2 by 6 log 2 by 6 to the base 2. For senior, we did 2 by 6 log 2 by 6 to the base 2. Whatever value you get is your split info. Now what you do is, gain ratio for age is going to be the information gain for age that you've calculated divided by this split info. You get a value. The same procedure you repeat for income also. Whichever value comes out higher is your splitting point. I hope all the 3 indices are clear. Information gain, Gini index and gain ratio. Go through it once again. You can, since this is a video lecture, you can just hear it out again, solve it on your own. I've given you a set of practice questions. If you see here are your practice questions. The first one is for information gain, the other one is for gain ratio, and the third one is for Gini index. I'll be sharing it with you, so you can just solve these questions after the video lecture. All right. Okay. So since we are done with this, we can move on to the next part, that's called pruning. Okay. Now in this example that we were discussing, we had got only 2 attributes apart from the label. Now imagine a situation where there are n attributes and there are n values. So what happens, at the first place you calculate the information gain, say for example, for all n attributes. Then you divide it on the basis of one high attribute, the highest one, and then you again calculate for n minus 1. Then you do it for n minus 2, n minus 3, and so on. And this process goes on. So it's going to be very long and very redundant. And I don't think that much of a computation flexibility or time availability do we have in case of getting a good result in time, of course. So what happens is that there has to be a stopping criteria. For every algorithm that you've learned so far, there's an important characteristic that there should be a stopping criteria. It cannot go to an infinite loop. Of course, this is not going to be an infinite loop, but it is going to tend to near infinity, because it's going to go on and ultimately the computation is going to take time. So what happens here is that you've got 2 stopping criteria that will help you decide when to stop computing or checking. The first one is that you are either supplied with the domain knowledge or some constraint given, we'll see how. And the other one is that you've been given the depth of tree. Now, okay. On the basis of these 2, what we do is we prune the tree. Pruning means cutting it off. Pruning are of 2 types. We'll be seeing that further. We'll say case 0. Now, if you have already been told that the maximum depth allowed in your decision tree is 2, what you do is your depth is going to be this attribute 1 is your level 0, level 1 and level 2. So the total 3 attributes will be allowed. So after these 3, you need not even check further for any of the attributes. All right, this is what they mean. And also what I mean by 3 is that attribute 1 and attribute 2, and this is going to be your leaf nodes and not any other attribute, which ultimately means that if they say that you have got depth 2, you're going to have only 2 attributes, the first one and the second one, because the third layer is going to be leaf nodes, that is actually your labels. All right, how do you do that? We'll see whenever we discuss examples. This is a part of theory so that you understand when do you have to stop. Whenever you are asked such questions in exams, you will be given the stopping criteria. Okay, so case 0 is clear that if they say the depth is 2, you will find out only 2 attributes. This is level 0, level 1 and level 2. Level 1 is attribute 1, level 2 is attribute 2, level 3 is going to be the labels. Okay, how the labels, I hope you remember. Here you can see these are the labels. So attribute 1, attribute 2 and the labels. This is depth 2. Okay, now here we come. Case 1. In the case 1, the constraint or the domain knowledge provided to us is that senior must not be granted loan irrespective of their income. Whatever their income is, if the age is that the person is a senior citizen, the person must not be given loan. So if this criteria is given to us, what do? Age, youth, middle and senior. Then for this subtree, we will calculate the information gain, and we put up income here. We calculate information gain for the rest of attributes and we put income here. But here we straight away write no as the label because of the constraint given to us. This process is called pre-pruning, that you are not even trying to explore what is the data set saying for income low, income medium and income high. You straight away put up a no here. You stop exploring a certain part of a tree due to the domain knowledge provided, which basically means you are halting the construction of tree, a certain part of tree. This process is called pre-pruning of tree, wherein while developing the tree, you halt the construction of a certain part due to a constraint provided to you. Now in the second case, you see here that there's no constraint given to you. Okay, what did we do? We found out age was the highest information gain providing attribute. So we put up age here. Age gives you youth, middle-aged, senior. You put up income, high, low and medium. Income, high, low and medium. Income, high, low and medium. This is your full grown decision tree. Entire decision tree is ready. For high, you get a yes. For low income, you get a yes. For medium, no. High, yes. Low, yes. Medium, no. High no, low no, medium no. As you can see here, all the 3 subsets are getting a no here. So after seeing this, you realize that rather than splitting it, what we do is that we can assign for senior, we can straight away write no here irrespective of the income. You were not given this as a constraint, but you observed this after your tree was grown. So since all the branches of this subtree get the same class, you remove the subtree. This is called post pruning, where you remove the subtree from a fully grown tree. So now what do? We convert it into this. These both are actually giving you the same result. But this is the case of pre-pruning when you were given the constraint. This is the case of post-pruning. This is called post-pruning, wherein you write it down when you write the entire decision tree, and what you do is you've noticed that there's a certain part which is giving you the same result irrespective of all the branches. So that's why you cut down the entire subtree and write a label there. All right. Okay, I hope this is also clear, guys. We can move to the last section, which is called decision tree to rules. Now, as you can see here, this is right hand side is a decision tree. You can always cast your decision tree into a set of rules or vice versa. From rules, you can make a decision tree. From decision tree, you can make a rule. Now you see here, outlook is the first one. Sunny, overcast and rainy. Sunny, windy, false and true. So if windy or not windy, like that. And these are the labels assigned. So what is happening here is that you first check for the outlook. So values for outlook, this is a different subtree. Now you understand that dark blue colored, this outlook, windy and humidity, the dark blue colored are actually your attributes. Sunny, overcast and rainy are values for outlook. False and true are values for windy, and high and normal are values for humidity. And yes and no are your labels. I hope you understand now. Again, outlook, windy and humidity are the attributes. Sunny, overcast, rainy are actually branches. The values for outlook, false and true are values for windy. High and normal are values for humidity. Yes and no are actually your labels. Okay, so what do we read here? The first rule says that if outlook is sunny, which means here, this side of the tree, and windy is false, which means this side, then play yes. The other rule can be if outlook sunny, windy true, play no. If outlook overcast, play yes. If outlook rainy, humidity high, then play no. If outlook rainy, humidity normal, then play yes. This is how you can write down rules from the tree, or from the rules you can make a decision tree. Okay, so this is it for decision trees. Classification using decision tree has got these many topics, and these are the practice questions from this topic of your unit 3. I'll be sending you these questions. I hope you do not have any doubts. In case you guys have any, you can write to me in the email like you've done last time. Okay. Thank you.